Hi guys! Welcome back to Sensors, Transducers, and Microcontrollers. I'm Neil Ravilios, and today I'm gonna teach you how to use a pH sensor and how to recalibrate it properly.
Before we proceed with the demo, let us discuss something about pH microcontrollers and the sensor's internal circuitry. pH. pH, or power of hydrogen, is a physical measure of the activity of hydrogen ions in water-based solutions. pH can range from 1 to 14. It is the negative logarithm of hydrogen concentration. pH levels below 7 are acidic and levels above are basic. Examples of acidic solution are acetic acid or vinegar, hydrochloric acid, hydrosulfuric acid, and etc. Examples of basic solutions are dissolved soap, bleach, baking soda solution, ammonia solution, etc. The pH sensor. The pH sensor is a device that measures pH levels by relating electricity to it. How? A pH sensor has two probes, with one being the reference probe and the other one being the pH probe. Reference probe is submerged in a solution of known pH level. When the pH probe is submerged in a certain different solution, a potential difference occurs between the two probes. The voltage difference between the two probes can be amplified and compressed into a voltage range suitable for measuring devices. Example, 0 to 5 volts for certain microcontrollers. A microcontroller is a computer in a single integrated circuit. It can be programmed to do a series of commands repeatedly. Analog voltage is a voltage measurement that could be as accurate up to 2 decimal places for some microcontrollers. The output pin of the pH board can be connected to a microcontroller's analog pin. Microcontroller reads the analog voltage and scales the voltages to a range of pH values depending on the formula given. The microcontroller then outputs the values via serial monitors. Here is an example of coding scheme for a microcontroller. And this is the internal circuitry of our pH sensor. Without further ado, let's proceed to our demo.
So, how does an electronic pH sensor look like? This is how a pH sensor looks like. It has a wire output which has two electrodes, one in the center and one for the ground. And it has a board when you buy it. So this board has an input that corresponds to the output of this pH probe. So what this board does is it amplifies the signal coming from the probe, and it also compresses the signal logarithmically from 0 to 5 volts so that we can read it using a microcontroller. So for the recalibration, I'm gonna call on my assistant, Mr. Soralio. So let's get on with it. So for the calibration, what we need to do is we need to dip this pH probe on something that we know the pH level of. But unfortunately, we don't have that thing. So I'm gonna teach you a little trick on how to calibrate this. Like I said, this board has an input of two probes. If there is 0 volts between these, that means the pH level is 7 because there's no voltage across this pH probe. So if we short this, we should have an output of pH level of 7. So I'm gonna call on my assistant, Mr. Soralio, to give you guys a viewing screen of our data. There we go. So for example, like I said, if I short this, we should have a pH value of about 7. About 7. So let's just wait for it to... Okay, so there we go. So it seems that so if I'm gonna remove the short now, so you are gonna see some change in pH levels. So it seems that our sensor is accurate after all, so we don't need calibration. But if we have offsets more than 0.03, let's say in the pH scale, we're just gonna input that on the code and update the code on the microcontroller. So I'm gonna provide the code too. So let's get on with testing some substances. Okay, so now we are testing some solutions First off, we're gonna need to remove the cap. We're gonna twist it like this. Next step is to wash it in spare water. So I'm gonna put it here in some spare water, just like that. The three things that we're gonna measure the pH of is Mr. Soralius drinking water, some vinegar. Unfortunately, I can't show you the brand, I'm sorry. And some soap solutions. So I think we're ready. May I see the reading, please? I actually have Mr. Soralio here assisting me so that he can show you our data. First off is water. So I'm gonna dip it in water and wait for it to stabilize. Mr. Soralio, may I see the data, please? So Mr. Soralio's drinking water has a pH value of 8. That means it's a little bit basic, it's still near 7, but it's unlike distilled water which has a pH value of 7, this has a higher pH value. Maybe Mr. Soralio is ordering alkaline water. Next step would be to wash it again in our spare water. Just a little bit stirring, but be careful not to hit the walls of the container or else your probe will break. Then just a little bit shake right here. Next would be the vinegar. For the vinegar, we expect our pH value to drop. Some vinegars, commercial vinegars, have their pH value from 2 to 4. So, Mr. Soralio, show them please. So I'm gonna put it here and let's wait for it to stabilize. May I see our data? So our vinegar has a pH value of about 2.7. So that's already acidic. But unfortunately, I can't show you some stronger acids because that's a bit dangerous and I don't like to corrode my probe. So next step again, we're gonna have to wash it again in spare water. Give it a little spin, and I think this will take a little longer than the drinking water because this is a bit more acidic. Next would be our soap solution. We expect the soap solution to be a high pH value because this is basic. So, Mr. Soralio, I'm gonna dip it here and let's wait for it to stabilize. May I see your data? So it seems that our device has disconnected, I think. So let me just reconnect it. Our remote device disconnected, so we're gonna have to reconnect it. So for now, we're gonna have the pH reading of, may I see? We have a pH reading of about 9.9, so that's too basic, I guess. So for this soap, basic level of pH. So that's that. Next step, we're gonna have to wash it again before storing it. So that's it, guys. That's the pH sensor, how we use our electronic pH sensor. But now for storing tips, if you bought one of these, they probably gave you some storing solution in little bottles, but I already ran out of that. So I advise you use distilled water for storing solution and change it for like every month, or depending on you, every 2 weeks, but just don't extend for every month. So fill the cap for about half level, then after washing your probe in clean water, give it a little shake, then you can store it in your distilled water. So store your probe in a place where it can't be accidentally stepped on. So I guess that's it for our video. So I'll see you guys next time. Thank you for watching our videos. Subscribe to my channel, Circuit Simulations, and tune in next week for the next episode.
So that's all for today, guys.
Bye!